Welcome to the Hyperautomation webinar for SAP Process Automation Technology. In this session, you will learn how SAP manages to optimize the ticket handling process for customers using SAP AI Business Services. This service is relevant to all of us here, especially during the COVID situation, because so many are working from home so as to avoid contact, which has moved almost all customer service centers online. That is one of the reasons that there is an increasing number of tickets that service centers are receiving, because that is one of the many channels by which customer service requests can get handled. So there is an overwhelming number of tickets received, and customer service agents also under big pressure to deliver exceptional customer service experiences because customer expectations are also increasing. This means excellent customer service will be a true differentiator for companies in the market now. On the other side, service agents also suffer from working from home because of the lack of real-time channels for getting feedback and guidance from more experienced service agents and from knowledge-based articles. This means there is a big gap between the increase in customer expectations and the capability of service agents to handle the overwhelming number of customer service requests in a way that delivers exceptional customer experiences. We can help reshape the ticket handling process in the customer service centers with SAP AI Business Services and help the agents maximize the efficiency of the ticket handling. The services included are Service Ticket Intelligence, Business Entity Recognition, and Document Information Extraction. How can we help recreate the customer service experience for support agents? Here is what happens if a new ticket comes via email or another kind of online channel. Service Ticket Intelligence will help you propose the potential categories for the ticket and identify the language, and will also do the sentiment analysis and propose a priority prediction for the ticket. Business Entity Recognition can help to identify such entities as the product ID, the date, the location. In short, all the relevant information in the ticket. Further, based on the content of the ticket, Service Ticket Intelligence will recommend a similar ticket that has been handled in the past for the agent to use as a reference when handling the current ticket. And if there are any attachments received together with the ticket, you can also leverage on the document information extraction to extract the content from the ticket and convert the attachment from, for instance, a PDF to plain text so as to make sense of the data that gets extracted. For instance, if an invoice is attached to a request, the invoice ID, the date, and the vendor ID and other relevant information will be extracted from the invoice as text. All these insights are generated right when the ticket arrives in the ticketing system. When the agent opens it, they already have access to all of this information. The agent is free from the repetitive task of extracting information from the ticket, which means they can handle the ticket faster and get back to the customer faster, which will make the customer happier as well. So this is an end-to-end scenario for ticket handling, leveraging AI solutions and also freeing agents and really reshaping the ticket handling process. Aside from the features that handle daily operations, we also have a ticket clustering feature that is also part of the Service Ticket Intelligence that helps generate insights about groups of tickets. So, for instance, if you upload the historical tickets for the last quarter, ticket clustering will be able to cluster the tickets based purely on the content of the ticket. The key words are identified and are provided so as to give you some insight into what this cluster is about. And the similarity scores here will show you how similar the tickets are for each of the clusters shown here. This is the purely unsupervised approach, and it provides very good insights for the topic experts in the service centers, so that they can go in and look at the tickets for a past period of time to see if there are any hotspots, any patterns, any trends occurring that might allow them to perform some follow-up actions. For instance, in this case, a majority of tickets are related to an uploading issue. The topic expert might be able to do something to sort out or improve the ticket handling for these kinds of tickets, so that when a new ticket comes in that is related to the file upload issue, the process of handling that ticket will be simplified. This kind of streamlining really helps increase the overall efficiency of all the service centers when handling certain kinds of tickets. Now in this demo, you will see how service ticket intelligence can be leveraged to create an exceptional customer service experience. First of all, you will go to the STI Explorer, where you do the end-to-end lifecycle management of machine learning solutions, from data upload to model training, to checking the model's performance, to testing, and in the end, to activating the model in the tenant. First, you click on the STI Explorer. Then you can see this Set Service Instance window, where you need to enter your credentials. You will get the credentials once you have your SAP account and are authorized to use Service Ticket Intelligence. You just type in your credentials and click Submit. Now you are logged into Service Ticket Intelligence with the API Explorer, where on top you can see 3 buttons: Create Classifier, Create Recommender, and Create Clusterer. These 3 buttons are used in model creation to create the corresponding models for ticket classification, ticket recommendation, and ticket clustering. Let's start with ticket creation for ticket classification. You click on Create Classifier, and in the window you enter a description. English is the language. In Upload CSV file, you will upload the training sample data set for classification. Here you can see that there are 3 columns. The first one is text and refers to the ticket descriptions. Label here refers to the categories that can be assigned to a ticket. And priority refers to the ticket's priority level. There are 19,000 tickets within this training dataset across 3 categories: Complaint, Complement, and Request. And for our priorities, we have High, Normal, and Low. The input column will contain the text. The output column that I want to predict is Label, which is the category, and the priority. You can also choose Increment on Existing Data Model. If you want to add the data from the new classifier on top of the existing data in the training set, and update the model with the new training data set. As this is not the case here, you would just press Submit. So this is the new model created from 19,794 samples across 3 categories. You can then click Train to start a training process. Depending on the volume of the training data set, it might take several hours to complete the whole training, so there's already a model created with the same training data set for this demo. You can see it's already here with the right accuracy. You can just click on this after the model gets trained to see what it looks like. After you click on it, you can see that first of all, there are some details about the data analytics of the training data set. You see the 3 labels: Complaint, Complement, and Request. And here are the corresponding numbers of tickets that belong to each label or category. You can also see the model accuracy or model performance with respect to the categories. We have Precision, we have Recall, and we have an F1 score corresponding to each of these categories. And we also have Mapping below that shows that the input field used in this training data set is text, and the output field used is label. One thing to also highlight here is that there is a criterion about the training data set to use for ticket classification. And that is that the minimum number of samples required to achieve good model performance is a minimum of 1,000 tickets per category. So in this case, you have a good quality data set, and you can see that the accuracy is also high. Now you can click on Analytics. This takes you to the page where you can get, first of all, the overall performance of the model, the precision, the recall, and the F1 score. These are the numbers that represent the overall model performance. The distribution of the volume of tickets is also shown here in a visual way. Now let's move on to the next section, which is the confusion matrix, which also represents the model performance. As you can see here, this is the predicted label. And this is the actual one. The dark blue ones are those that got classified correctly, which is pretty high. The last part of this model performance showcase is the diagram that shows the relationship between the model performance accuracy and the threshold. This graph corresponds to the model performance simulation and shows us the best threshold we can set for the model's performance. So what does this mean? It means that the threshold is like a confidence score that comes together with each of these inference costs. Each of these predictions will come with a threshold. If you set the threshold to 0.5, for instance, in this case it means a confidence score of 50%. So if the confidence score for each of these predictions is more than 50%, then it will get counted in. Otherwise, it will just drop the prediction. You can see that the higher you set the threshold, then the higher the model performance, as the blue bar represents. But the higher the threshold, the lower the automation rate, because there will be some tickets that will have a confidence score that is lower than 50%. The tickets with a confidence score of under 50% will be dropped. So with this graph and the information you have, you can select the right threshold to achieve a very good balance between the model accuracy and the automation rate here. This was the feature released under Service Ticket Intelligence in 2020. After the model is trained and after checking the model performance, you can move on to the next step, which is model testing. If you select Run Quick Test, it will take you to this page, where you can quickly test out the new ticket content to see whether the results matches the expected outcome. So, for instance, you can set the language to English, and the input fields will be text. Text indicates the ticket content, and the text will be, for instance, I had an amazing flight experience. You can see that this ticket should be categorized as compliment, and we will see what the machine will predict. Here are some additional options for choosing to detect language, detect sentiment, and see the top K categories that will be shown in the proposal. The top K categories will be the 3 categories we are already using, but they will come together with the confidence score. And here you can choose top K keywords, which are used to analyze content and that play a part in the machine's final prediction. After you select your options, you click Submit and see what comes out. Here is the classification result. The detected language is English, and the detected sentiment is 0.9. The sentiment will vary between -1 to +1, where -1 is super negative and +1 is super positive. Thus 0.9 means it's super positive. 0 is a neutral statement. You can see from the top predicted labels that compliment is predicted as the top one with a confidence score of 99.77%, which is super high. Complaint comes in at 0.21%, and request is only 0.01%. The top keywords in the text that played a role in achieving this prediction are experience and have and I. Let's try another one. The language is also English here, and text is also the input. Let's write, I have waited for a very long time. It's a frustrating experience. You will then select all of the options like before because you want to see how well the model can predict the outcome. So you can see here that the new ticket's detected language is English, and the sentiment is -0.4, which means it's minor negative, not super negative. It is sort of in the middle, and the top label prediction is complaint, with a confidence rate of 99.33%, which means a very low confidence rate for labeling this ticket as a compliment or a request. So this is pretty accurate as well. You can see that the top keywords in the text help explain a little bit of how this kind of machine learning solution works. So frustrating and waited and time played a big part in the prediction. You can also click Run Classification, which means you can upload a CSV file in which you have a list of the ticket content classifications, and then get a list of the results altogether, instead of doing each ticket one by one. We won't show this today in the demo due to time constraints, but you can try it out for yourself. Let's now move on to the part about ticket recommendation. The ticket recommendation, the file upload, and the model creation will be very similar to ticket classification. You can see in the Create Recommender window here that you can choose a CSV file to upload, then identify the input and output columns, and then click Submit to create the model. Here is a model already created using the same training dataset. Take a look at this page that shows the analytics for the training dataset. One thing to note here is that for ticket recommendations, the criterion for good model performance is that the number of training samples should be a minimum of over 10,000 samples. This is a bit different from ticket classification because ticket classification takes into consideration the various categories. You can see from the mapping here that the ticket recommendation input field is text, and that the prediction fields are the ticket ID number and text as well. So the machine will compare the similarity of the unstructured text contained in the ticket to other tickets. You do not use any category as part of the output here, which is why categories are not specified, and the number of tickets needed is different. As mentioned before, you will want the quantity of tickets to be at least above 10,000 to achieve a good model performance. You can see from the mapping here that once we get the model trained and we have a new ticket, you will see a recommendation about the ticket ID and also the ticket content of a similar ticket. If you go back here, you will see that you also have a Run Quick Test and also a Run Recommendation button here, so you can test the process for the model you have created. For Run Quick Test, using the model you created, you identify the input field as text, and you can enter text here that will be a request. Can you help me check the status of my booking? And this becomes a new ticket. As an agent, you want to know which are the top 3 tickets that were recently closed that are very similar to this new incoming ticket, and you can see those here. The top 3 similar tickets all have a confidence score of 0.85%, so there's the ticket ID and also the text, and the text for all 3 say, "How to check my status." This means this group of tickets is fairly similar to the newly created ticket, so they are recommended to the agent who can refer them to facilitate the handling of this new ticket. Let's try another one. This is a very positive one and is a compliment, just like the top 3 recommended comparison tickets. The first 2 have the same similarity score of 0.75, denoting super-fast consumer service response via Twitter. You see the full range along with the ticket ID. The third one shows a recommendation score of 0.72, and with the ID and a thank you message to customer service for fast help. So again, these tickets are very similar. Overall, what you have seen today have been good prediction results, but you should know that there is also a wrong recommendation option that also includes a CSV file that is available to upload. You can see a list of other tickets with various levels of similarities and how the ticket recommendation engine handles them. The back upload of tickets for testing is available here. Finally, we have clustering, for which the creation process is also very similar. You just click Create Clusterer, and you see in the window the fields for description and language and upload CSV file, and you identify the input and output columns, after which you create a ticket. If you're interested in knowing more about ticket clustering, we have a separate session in which we show how it works in different use cases. And there is also a demo in which you can use a Python notebook to interact with our APIs during the session. You can find the link in the description. To recap this session, here are the key benefits of SAP AI Business Services for improving customer experience. We started with the SAP AI Business Services solution by trying to maximize the insights that can be generated from the ticket content, including the ticket title, the ticket description, and also the attachment. With this done automatically, agents can really be free from repetitive tasks and focus on higher value tasks. They will provide faster and better services to customers, and of course, customers will be happier. Further, with the help of the AI technologies and the thousands of tickets received, you can also identify some of the patterns that would never be explored or discovered before. You can use these identified insights and patterns to streamline the ticket handling process in the service centers. So, SAP AI Business Services can really help you to reimagine and reshape the customer experience.